Hello students, so let us continue this topic. So in this video we are going to discuss about the concept of gravitational field. Gravitational field. So what is gravitational field? Gravitational field is the space around a mass where it can apply gravitational force on any other mass, or masses kept at that location. So basically you can say that it is the zone of influence. Zone of influence means the zone or the area or the space around the object where it can apply force. So suppose that this is a mass. Generally we tell that it is the source mass, and because of this source mass we want to calculate the field due to this source mass. What is source mass? Source mass is the mass which we are studying. We are studying the influence of this mass near to its location, right? So if you take any distance, let's say r distance away from it, and you bring another small mass, this is called a test mass. Test mass is a very small mass. It is a very small mass. This is small so that it should not disturb the source mass, and its influence of the test mass is negligible. That's why it is small. So what will happen? This test mass will experience force, and the force will be in this direction, right, towards the source mass, and this force will be Gm by r square. Now the field, how do you define field mathematically? How do you explain that? So mathematically we define that as a field intensity. Gravitational field intensity gravitational field intensity, or strength, or field strength. That is defined by the symbol E, which is the field divided by this mass, and we apply a concept of limit. This mass is very small, so that it should not disturb the source mass. So you see this will become Gm by r square. Of course you can use in terms of vector. You have to put minus sign if you are writing as a vector, but here we are writing magnitude, but vectorially you can write it like that, because this is always towards the source mass, right? So field due to mass, if you want to represent, you can represent like lines which are going directly towards the mass. So these are the lines radially inward, inwards. These are called field lines. Field lines are radially inwards. Okay, field lines are radially inwards. Okay, but now if we want to calculate field due to distribution of charges, so due to each of the point mass you can calculate, and you have to add as a vectors, because force is a vector, so field is also a vector, right? And there can be various results on this calculations of the field. So some of the important results we can summarize. Okay, so let us summarize important results on field. Important results on gravitational field. So first result, you can say that the fields are straight lines. For a point mass, field lines are like this. Already I have discussed, field lines are like this. I am just drawing some of the field lines. Let us say this is a point mass. Okay, point mass. Field lines are radially inward. Field lines are radially inward for a point mass. And the formula for field is given as minus, if you give the sign, minus g m by r square. Here m means that mass, source mass. If you want, you can write the source mass with a capital symbol. Generally, source mass is written with a capital symbol. So at a distance of r from this, the field is given by this. And of course, field will be directed towards that. Magnitude wise, you can simply write Gm by r square, but vectorially you should put a minus sign, so the field is going towards that. Okay. Then another important result that you can note is what about the distribution of masses? Vectorially we have to add the field due to each of the masses, and let us consider continuous masses. So in continuous masses you can take linear rod with uniform mass distribution. So let us consider continuous masses and linear rod. If you consider rod of length E and B, so mass is distributed over the rod, and we want to find at a perpendicular distance of, let us say, r, what is the field here. So when you want to calculate field here, let us say the distribution of mass is lambda. Lambda is linear mass density. What is meant by linear mass density? It is mass by length. Okay. Now because of this, there will be a field. So here the field, resultant field will be there. Okay, so let us consider the resultant field in some direction. Let us consider this direction. Of course, in general, I can draw another direction also, but of course it is attractive, but just for that I am drawing it. Theta, this is the net field, and this is, let us say, x-axis, this is, let us say, y-axis. Okay, so what is the field here? Net field. We can calculate field along x-axis and field along y-axis. So g lambda by this distance r, we need to here also note that we need to join these 2 points. Okay, and you can assume that this r distance is there, of course. This distance is r, but let us say that this angle alpha and this angle is beta. So you can write along x-axis sine alpha plus sine beta, and this one is g lambda by, this is also that same, this is cos beta minus cos. Okay, this formula you can remember, you can derive it also, and here you note that this is the magnitude only I am writing. Okay, so tan theta can also be calculated as Ey by Ex, right, which will become cos beta minus cos alpha by sin alpha plus sin beta. Okay, right. Now what is lambda? Lambda is mass per unit length. What is r? R is the perpendicular distance of the point from the rod. Here we have considered finite rod. This rod is considered as a finite rod. What will happen if the rod is infinite or very long rod? Very long rod. In very long rod, you can see that Ex will remain, Ey will become 0. And what will be angle alpha, beta, alpha and beta is going to be equal to 90 degree. Okay, so net electric field will be only along Ex direction, G lambda. This is 1 sin 90 sin 1, 2, it will become 2 by r. And along y axis that is going to be 0, right? Okay, because cos 90 degree and cos both cases will be 0. Okay. Similarly, we have various other results that we can derive. It's better to go through derivation. Here I am just summarizing some important results. Why are we calculating field? Because once you know the field at any location, you can calculate force is equal to mass into the field. Okay. This formula we can use to calculate. Further we will discuss in detail. Thank you.